We are now on question number 1, and that's exercise 7.2. It says, in an isosceles triangle ABC, where AB is equal to AC. So let's make an isosceles triangle. Let's make an isosceles triangle. So this is an isosceles triangle. Further, it says that the bisectors of angle B and angle C. So this being the bisector of, say, this is angle B, and there's another bisector that's for angle C. So the bisector of angle C, say this one is the bisector of C. So the triangle is ABC here, and this angle is equal to this angle, as you can see. Say I named it angle 1 and 2. These are the bisectors, and you know that in a the bisectors bisects the angle into two equal angles. So this is angle 3 and angle 4. They meet at point O. So let's take this point is O. It says join OA. So let's join OA. I joined OA. Joined OA, right? And then we have to show that OB is equal to OC. We have to get this length OB is equal to OC. Now, as you know, whenever we have to prove two sides equal belonging to two different triangles, we prove it congruent. So ordinarily, all students at this stage will think of proving these two triangles congruent, right? But it cannot be done, right? As you do not have sufficient information to prove the triangle congruent. But besides that, OB and OC also belongs to a triangle, that is this one, that is this triangle called BOC. And as you know that in a triangle, if two angles are equal, then we can write their opposite sides equal using isosceles property. That's what we are going to do in this question. So let's start with this triangle. Let's consider the triangle. First, we will consider triangle ABC, where the length of AB is equal to AC. So using this property called isosceles property, we can write angle B is equal to angle C. This is isosceles property. And it says that angles opposite to equal sides are equal. I repeat, angles opposite to equal sides are equal. So this side being equal to this side, so the angles opposite to this and angles opposite to this will be equal. So angles opposite to equal sides says that here angle B is equal to angle C. As you can see that we can replace this angle B with twice angle 2, as it is a bisector and angle 1 and angle 2 are equal. So is on the other side, angle C can be replaced with twice angle 3. Let's cancel these two. So we got angle 2 is equal to angle 3. Now, in this triangle, that is triangle BOC, what we have obtained angle 2 is equal to angle 3. So this implies that when two angles are equal, then their opposite sides, that is OB is equal to OC, using the same property called isosceles property. Over here, what do we say? That sides opposite to equal angles, as this angle is equal to this angle. So the side opposite to this angle and side opposite to this angle, that is OB and OC, should be equal. That is the first part. In the next part, they are asking to prove this AO bisects angle A. That means we need to prove this angle and this angle as equal. Let's say I name it as angle 4 and this being angle 5. Now here we have to prove the two triangles congruent. The two triangles congruent that we need to prove is one is this triangle, and the other being this one. Right. See how can they be proved congruent? Number one, we already have these two sides, that is OB is equal to OC proved above, and this length AB is equal to AC, and OA being the common side. So we can prove this two triangle congruent. So let's consider these two triangles. I'm considering the triangle here that is AOB and the other triangle that is AOC. Same as we discussed, we have the length AB or the side AB is equal to AC. This was given in the question. We have OB is equal to OC, and we can write this as proved above. And further, the length AO is equal to OA. That's a common side. So we simply write common in this case. So therefore, we can write this triangle that is AOB congruent to triangle AOC. Now, once we prove this triangle congruent, as you can see, these triangles are congruent by side, side, side. After proving this triangle congruent, I can simply write angle 4 is equal to angle 5. That's from corresponding parts of congruent triangle. And this implies that AO bisects angle A. And that's how the two parts of this question can be done.